Okay, you don't need to. It's an audio synchronization when I need to record in different places because usually I do recording in externally. So thank you, Spears, for introduction. Probably most important slide. If everything was going to work out, video and slides will be available on this website. The video should be available like right after meetup. I will upload when I get back to my hotel. This is presentation. There will be some bits of Java. There will be a lot of bits of Kafka, obviously, and the way how this presentation actually started, someone asked the question in Twitter about, so a couple of years ago, I worked at a company called Sartre, yeah. And we were building a real-time analytical database based on Apache Pinot. And there was a question from one of the community members saying, hey, like when you need to use Kafka Streams, or it's good to go with the full-blown real-time analytical database like Pinot. And it turns out to be a very deep, that's my current boss here replying, yeah, that might be a very good idea for a talk or podcast. And it turns out to be like a very big multi-year research project that I'm endeavoring right now. Rumor has it, it's actually not rumor, there is a 8 episode of live stream show where I'm breaking down each use case. Today we're gonna get like compacted version, kind of like a distilled version. If you want to go deeper, I'm doing like every 4 weeks I'm doing a live stream when I'm breaking down these technologies. So today I'm going to be talking about how to query a stream. This is a question everyone might ask. All the roads lead to Kafka. Your streams are already in Kafka, I assume. That's my life. I don't know how's your life, but my life is pretty good because my streams are all in Kafka. And how to query this, like how to get insights of this information. I'll give you some framework about how I think and how I approach this problem from perspective of what type of streams I want to query, what kind of information I want to get from this. Can we do a quick show of hands so I can understand like where we are in our Kafka journey? Anyone is using Kafka today for development or for production, or at least to understand difference between partitions and consumers? Okay, few people still maybe not understand difference between consumers and the partitions. So I'll try to be like where it's important. I will make assumptions that you understand what I'm talking about. If not, shout out, like saying, "Hey, Victor, stop! I don't understand." It's fine. It's totally fine if you want to do this. I'm here for you. My flight not gonna leave until tomorrow afternoon. Taxis are not going anywhere, so I'm stuck with you, you're stuck with me, and I will not leave this property until I answer all your questions. My name is Victor Gamov. I work as a principal developer advocate at a company called Confluent. You already know that Confluent was founded by original creators of Apache Kafka. We built a managing platform on top of Apache Kafka. I will be using our platform to show some demos, but all these demos are relevant for any Kafka implementation. If you're using open source Kafka, if you're using Confluent platform, or any type of Kafka compatible solutions that are available there. Kafka become a kind of very ubiquitous protocol for data streaming. So the systems that they're trying to do something with data streaming, they try to appear to Kafka as well, or at least they have some sort of compatibility layer that allows you to. For example, there's a Warp Stream solution. Anyone heard about Warp Stream? It's a pretty cool tool that allows you to run your Kafka-compatible brokers on top of your S3 storage. So if you are able to sacrifice, say, latency, you don't need to have like a sub-seconds or milliseconds latency, but you're okay with the latency. We have a few hundreds of milliseconds. You can run like stateless brokers on top of S3. Warp Streams provides a Kafka-compatible solution, and also this stuff will be available. I wrote a book about Kafka. If you're interested to pick up, let me know. I'll maybe send you a discount if you want to get this Kafka in action from Manning. That's I did. And with this, let's gonna start with the yes, all the slides, obviously, it's 2025. Slides are all AI generated. I use the ChatGPT ability to generate the slides in style of Ghibli cartoons, so you'll see a lot of anime stuff. And how people found the Kafka and how we like the story about Kafka, where it fits very well. And the speakers was already talking about how they use the Kafka as the place where they broke down the monolith and microservices will communicate. So everything starts with monolith, and it's easy because easy to think about this. Your tables are there, your data is there, so you just go there and use SQL to query those monolithic data, monolithic systems. So your data in one place. You don't need to do anything with this, so you kind of feel comfortable of doing this query. I understand it's going to be weird talking about SQL in Java meetup. Is it Java meetup or it's Kafka meetup?
It's both of them.
Both of them. Okay. So, like personally, I am when I started my journey in software engineering 20 years ago, I was like why I need to learn this freaking SQL? It's weird. I love Java. I have Hibernate, GPA, and stuff. Why I need this? And yeah, apparently SQL still going strong like 20 years after, and we're going to talk a lot about SQL. Now, so when the people start either breaking down monolith or trying to move data to another system, for example, there's one system that does everything. It's monolithic system, but all of a sudden there's another department interested to run some data, run some reports on top of this data. So they want to get this data in a certain format. Maybe they want to have it in kind of like in a reporting or analytical format that would be very suitable for running those reports. So this is why we come up with these ideas of ETL, extract, transform, load. So we extract the data from the source system, we do some sort of transformation, and we load this into target system where we can perform whatever task we want to do. It was quite successful times, it's quite successful runs. There's quite successful businesses were built on top of this ETL idea. Any Informatica people, anyone writing batch jobs themselves for ETLs, hopefully not because it's Java people. Usually Java people not doing this. Another flavor of this data integration pattern where we go in a little bit deeper. So usually ETL runs on top of this kind of like the available public interfaces like a SQL, JDBC, something that you connect to external system. You not bother anyone. You just extract this data. You do whatever you want to do this, massage this data and transform this and load to your system. With CDC or change data capture, you're actually tapping into the source of this database. Some databases provides this interface that allows to listen changes that happens on database side of things. When something happens on the database, before it would be materialized in a table or view, it generates internal event that will be written in the write-ahead log or some transactional log in your database where this stuff can be extracted and also moved to another place where it would be restored and materialized into something that would be used for target system. Now, those things are good, and those things start to be used not only for data movement, but also for some sort of data integration. So CDC was the pattern that allows to enable some of the event-driven microservices on top of the legacy system. You have some existing system that you're too afraid, or it's too fragile, or it makes too much money, so no one is touching this, but you still want to do some new technology. So now you tap into this system, you get these changes, you push these changes through this, very interesting technology that we're going to be talking about called Apache Kafka. And after that, your event-driven microservices will listen for these changes and will make some decisions based on that. So you have your, like a payroll system that loads all the data into this, from mainframe, we get this change data capture thing that will gets all the updates from the current month. And after that, we can do some interesting microservice that will generate reports, some microservice that will generate the pay slips, microservice that will, calculate bonuses or things like that. And it turns out that this technology that was running underneath inside this database with the write-ahead log or some transactional log can be actually used as a foundation for new type of the data system. So people in LinkedIn think about this. Okay, how we can actually turn this database inside out and provide this interface that is available inside the database as a primary interface to communicate. And they use this data structure called log, which is append-only file. You need to think about this as just something that grows, you will not update, you just only write into the end of the file. So that's why the reads would be sequential. You're reading from beginning of the file until the end of the file. It's probably one of the 3 most important data structures that you need to know for any type of like a data systems or for data engineering. Another one would be something like a B-tree or something like that, and obviously hash map, right? So anyone is asking hash map question for interviews these days? Anyone?
Yeah.
So that's actually a pretty cool question, because I was involved in another open source project back in the day called Hazelcast, and this actually was distributed hash map. And the way how hash map works in your local thing is actually makes a lot of sense how this will work in distributed fashion. And the Kafka actually uses some of the similar ideas, because Kafka has a key, and the key would be used as your the hashing logic would be used to tie together partitions and producers. Now, it's append-only, data only would be written. Imagine that data never expire. This log will be constantly growing. Obviously, for the sake of practicalities, there's some of the mechanisms that allow to expire some of the data. But if you think about this, you have this ever-growing log, wherein you're just appending data in. Now, so we took this data from the systems. Either it's going to be change data capture, or it would be ETL process, or it would be some of the messages that would be natively processed, produced into this log. Data would be written into this log. Now, what are we going to do with this? And we can do actually 2 things. So remember, I was talking about this turning database inside out, meaning that we capture this data stored somewhere in distributed fashion. It would be fast available for writes. It would be consumed also very fast. But by the end of the day, we want to make up something of this data. And there's 2 things that we can do with this. Same way as we have 2 type of major databases that use for online transaction processing, and for some like ETL stuff, or for some reporting stuff, OLAP, what we call online analytical processing. So from the streams that we capture in the Kafka, now we can derive 2 type of streams, is OLTP streams and OLAP streams. So in one, we would be interested in one particular event. We would be interested in one particular thing that happened. Give you an example. We have all these events that happen on credit card transactions, right? So, and we're interested in one particular transaction, or we're interested in set of transactions from one particular credit card. So, based on the key, that would be our the credit card number, we want to get a list of transactions. Or based on the combination of credit card number and date, we can get one particular transaction. So that's going to be our OLTP stream. So where we usually involves key lookups. And it kind of makes sense when I would personally start learning about Kafka and came from NoSQL databases background. I was thinking, okay, so they have a key, they have a value. So is it that how I can query this by key? It turns out it's not that simple. So that's why this is kind of like a very interesting case that we're gonna talk about, how to query this the stream by key. Now, second one, with the OLAP, with the analytical use case, we're more interested in the story. So instead of learning about like individual transaction or individual credit card transactions, we actually interested, say, how much money we spent last month on the groceries. Same amount of data, same data, still capturing transactions from the credit card. But the outcome that we're interested in the story. Instead of individual transactions, we're interested in the story. Does it make sense for what I'm trying to say? So that's why I structured this talk in some of the use cases that I will be bringing this up in the sense where we will be talking about either for OLTP, operational data, or in analytical data. All right, so the candidates, the usual suspects, what I'm going to be talking about today. Things that you can use to query the stream. So we're going to start with some of the what I like to call in-store brands. Something that is available out of the box you can use today. You don't need to go like very crazy and discover some other systems and learning from some new technology. So Kafka Connect and Kafka Streams. So Kafka itself, Apache Kafka, it's a big project that includes multiple different components. Apart from the broker itself and the brokers and there's also components that allows you to do this integration. So the Kafka Connect. Anyone heard about Kafka Connect before? So yeah, a few people. Nice. Okay, we're gonna go a little bit deeper on this, but yeah, not so deep. And Kafka Streams. Kafka Streams, it is also a built-in framework that allows you to write stream processing applications. So think about this in the sense of ETL. If we're gonna talk about ETL and streaming ETL, so Kafka Connect allows us to do E and L. So it allows us extract data from external systems and also load to external systems because it has two types of connectors that allows you to bring data into Kafka and ship data outside of the Kafka. And Kafka Streams allows you to perform T, transformation. So, but also we're going to be, I'll show you examples of how it can be used for query for our stories. For the last 5 years, I've seen the emergence of this new type of software that we can call streaming databases or streaming SQL. I will give you some of the ideas how you can identify those new type of systems so you can clearly categorize it into one place or another. We're going to talk about, since I've been in this space, and I think it's also very, very good example of the system that allows you to query streams, real-time OLAP. It kind of sounds kind of like weird, right? It's OLAP and it's real-time, how this will work together. Data warehouse, data lake, because Kafka can be delivered, Kafka Streams can be delivered to those places, and those places have certain capabilities to query this data. I'll talk about this one as well. And at the end, I want to talk about very interesting piece for me. Hopefully, you also would be interested. Technology that enables these, I think, the pinnacle or evolution of this processing and the how to query stream type of thing in more in a fashion where it involves less infrastructure or less hustle. Hopefully, I will see. Now, any questions so far? Does anyone miss something from this list that they wanted to see, but I didn't mention? So let's do this one more time. When it's quiet, there is one of two things: is everything is clear or nothing is clear. And since you're quiet, it's very difficult for me to understand which one is which. So talk to me, please. Let's have a conversation. I understand you kind of cozy. It's getting like a warmer. It's dark. It's the after. So let's talk about Kafka Connect. So essentially, Kafka Connect in-store brand, it's a framework. Kafka ships with few out-of-the-box connectors, but majority of the connectors will develop either in community or developed by vendors. Usually what has happened in 2025, some of the connectors we developed at Confluent, some of the connectors vendors of the system, vendors of databases, they developed, and they also support them going forward, so we can build this integration system. When I say like a smaller data, I mean in the sense that you still can run the terabytes of data in Kafka Connect. It's going to be fine. It depends on like how comfortable you will be running another kind of like a smaller database next to your Kafka workload. Specifically, I will be using example of traditional SQL relational database because I want to cover both cases. I want to cover like OLAP and I want to cover OLTP case as well. Historically, like originally, it was designed for transactional data, meaning that individual record is important. So that's why we have this like ACID compliance system, right? So we care about atomacy of transaction, we care about consistency of the data. So if there will be multiple records will be recorded within one transaction, we care that the consistency will be preserved. Transactional isolation, so different actors will not be able to interfere on top of the same data. And the durability, obviously, we're going to store it somewhere in on the file. But many people still use the traditional OLTP databases for analytical use cases, right? So every time you're running like a count or some sort of like average sum function on top of your Postgres, that you do in analytics. And users are familiar with this. Like I said, the SQL is still going strong, and it's maybe it's another bad thing. So the way how it works, have a Kafka cluster. We have a Kafka Connect process that will be reading data constantly from the topic. It's kind of like we'll be batching this, and after that we'll be storing somewhere that you will be able to query. So for my example, and by the way, what I was talking about, all these videos are in Confluent Developer YouTube channel. So if you want to subscribe and pick up some of the ideas, all these videos, say for example, how to query stream. So they are already recorded here. If you want to go deeper look, just if I forgot to mention. Now, I do two things here. I'm running my Kafka Connect process as a separate container. You can run this as it's a Java process. It's a Java process. Containers is just a simple, easy way for running things and sharing the things, because the repository with this example is also available. And also, I'm using like an extremely powerful database called SQLite that runs like in a million devices around the world. So like probably you have at least 2 devices on you right now that run SQLite database. And in the case of my use case, that's what happens when I'm talking too much, and the system will log me out from the system. Okay, so as example, I will be using some synthetical data that will be generated flights. I spend a lot of time in airports and lounges, so I think that, why not use this information for my demo? I do have some data generated that constantly pumping this data in my Kafka topic, and individual message would look something like this. We'll have information about airline, flight number, just randomly generated data, and there's a lot of data. This data would be dumped into my Kafka topic and in a regular basis. Now, so when I want to do this, I want to do 2 things. One thing, I should be able to query this data and getting some like a transactional use case solved. It's obviously easy to solve because you know SQL. You can do select star from flights where flight number equals blah, and you get this information. And also, I want to run some analytical workloads. Say I want to get the information about delayed flights. So in this particular case, I have a connector that will be reading that data from this topic and dumping this into this SQLite and this SQLite database. And the thing will look something like this. In my Where's my Docker Compose? Do I have it, Docker Compose? My Kafka Connect infrastructure will be available from this base image. I need to install a plugin that will be allow me to connect to external systems through JDBC. And I need to install JDBC driver for SQLite. And after that, I will be able to do something like this. So let's run something like, for example, count. This is number of messages that were pulled from the Kafka topic. Now it's running on my local machine inside the SQLite file. If I will run this one more time, this number should change, but it didn't for some reasons. Let's see one more time, because this should change. This is something that we can see what is happening. From perspective of this is my connector? Yeah. So my consumer should be here, and I can see a consumer lag. Should be reading. Should be reading. Let me see. We can check if the connector has any issues. No, connector is running, is up to date. So let's see. Make TPC. Do we have a status? Status. Yep. So gDPC connector is running. Maybe there's some lag because of the internet or maybe something like this. And now I also will be able to do KC, say, flight delays. Where is it? Query delayed flights. So run the query to get only delayed flights and getting the status like why it was delayed. So let's take a look on the actual query. Where is it? So we are querying flight status, and let's see, delay. Yes, delayed flights would look something like this. We get information about flights, where actual departure is not null. So sounds familiar, nothing really, to call home about. So that's the first solution that you can employ because you already have some database that available to you, spin up Kafka connector. You can manage connector yourself. You can run this in container. You can use managed connector inside the Kafka cloud. You can do whatever works for you. Also, I can do stuff like, say, airlines. Flights per airline. So that's kind of like another analytical use case that you can run on top of this data. So it is something that you can do easily without employing any other new systems or whatnot. Obvious for me, but I'll try to make it obvious for you. So it is kind of style of micro batch. So it will connector will be reading data based on the configuration. It can be reading per message and after that dumping this back to database, or it will be reading in some sort of batch and after that will be updating those. So there would be some delays between how data available in Kafka topic and how freshly it will be available in your system. Also depends on the size of your topic. You want to start thinking about like how much information you want to store in this database, how much would be to take in for SQLite, and where you need to switch to Postgres, and when you need to switch to distributed Postgres, and after that you start kind of like questioning your life choices, how far you can go with this. So that's why the people usually asking like, well, you mentioned this, it's suitable for smaller data, smaller-ish data, because at some point the size of information that you will be holding in this database would be big enough, so it will be a problem by itself. You need to figure out about indexes, you need to figure out about storage, so far and so on. So now let's go with another thing. So another approach to deal with the data integration, like I said, it's kind of more stream processing. It's already assumes that data is in Kafka topics because Kafka Streams has very intimate connection with Kafka architecture specifically. Data can be ingested only from Kafka topic. There is a concept of key stream and key table that also would be kind of like influenced by how the data is structured in Kafka topic. So you will have a key value. Key would be type of the key would be defined as a key for key table, and value will be defined, obviously, a value from the Kafka topic will be defined as a value inside the key table. Inside this application, this data will be available in key value star. So that's why I mentioned, like we're starting with log, we're learning about log as an important data structure. Now we're getting where? Hash map, because key value in memory store. What's hash map? So inside this application, we will have access to this abstraction that allows us to build in-memory representation of whatever we're processing. I'll show you in a second. Now, it is scalable across consumers in the consumer group. So this is the point where I kind of like usually divert and talk a little bit about how the consumers and consumer group scaled. Who needs this lecture? Okay, one person, two people. Okay, so I'll talk about this. Imagine you have nest with baby birds. That's an interesting turn, right? So you didn't expect that. Okay. So with these baby birds, there's mommy bird. And mommy bird brings some food for baby birds. And usually it will bring some worms, because the worms look like good representation of the log. So nest will represent a consumer group. Baby birds will be representing our consumers, and mommy bird will represent consumer group coordinator. So the way how Kafka scales reads, we have 3 consumers, and mommy bird will have 4 worms that will represent our partition. So consumer group coordinator, aka mommy bird, will distribute those worms across this baby birds. So in this case, we have 3 baby birds with 4 worms. Some of them will get a little bit more. So this is how the consumers will work. If you have, say, 4 baby birds and we have 4 worms, each of them will get its own. What's going to happen if we will have another baby bird will hatch and we have 5 baby birds in the nest and we have only 4 worms? Not entirely. Not. It's eventually maybe. It will be hungry. Yes, it will starve. So in the world of Kafka, this consumer will be idling. It will not be consuming any data. So what's going to happen if this says the opposite situation? One of the baby birds will fall off the nest. So mommy bird will stop the feeding process and redistribute the baby birds, the worms across the rest of the baby birds. So we have, say, 2 baby birds and 4 partitions. Each of them will get 2 partitions. Does it make sense? Okay. So the way how the application scale in Kafka world, number of consumers in consumer group will define how you can scale. And the Kafka Streams has a lot of built-in architectural kind of decisions and APIs and things that you need to know that was based on that. So if you have a say topic with the 1 partition for some reasons, there's some legitimate reasons why you want to have that. It doesn't make any sense to run more than 1 instance of Kafka Streams, because other instances will be just idling. So Kafka Streams actually use this for benefits. So you can actually run what they call standby instances for faster restart and things like that. But it's kind of beyond the conversation of today's this point. Point is, scalability of the framework will highly depend on those concepts that's built in Kafka. So that's why scalable across multiple members in the consumer group. So number of partition matters in this case. And you need to it's kind of like an abstraction that leaks into your application where you need to start thinking about those things. And there's an interface that allows to talk to this in-memory key value store and also expose it to outside world. Say you can wrap this into REST API and make your Kafka Streams application expose this data in a REST endpoint. Analytical use case also very similar, but in this case you will be kind of going very deep into Java style of API. So anyone using Java util streams? Anyone using Java older than Java 8? Which version are you using this if you're not using version of older than Java 8? Which version of Java are you running? 17. 17, okay, that's more than 8, right? So you kind of familiar with the Java util streams, right? Java util streams is a cool API that came as an API for performing some actions on top of collections, right? Kafka Streams had this style of API even before it was available in Java 8. It was available since Java 7, and it also supports a single metal interface, and so all this kind of stuff. So you will be able to write applications that are very similar to what you do with your, the Java collections. You can do counts, you can do sums, all sorts of aggregations, this data also will be available through key table. So you will be able to query this also through iterative queries. So let me quickly show you this example with Kafka Streams. Again, same use case. We have a flights from the topic, and I want to have one use case that allows me to do analytical stuff, and another that allows me to do the OLAP stuff. So, this is my Kafka Stream dashboard. This is my application that runs this small web server called Javelin, I guess it's how it's called, and it wraps my interactive query service and expose information that Kafka Streams will populate. For example, let me see if we have any flight numbers. That's kind of like flight number that I can use, and I can go ahead and query this flight not found. That's embarrassing. Let's see if we can find some other. Let's see if we can have. Let's see, delay it one more time. Maybe there would be some updating. Oh, okay. So this one and flight not found. Maybe this something is happening, but the idea is that it's supposed to show the flight number that is available. Let's see if it does. The way how it works in this case, we do have a few things. Kafka Streams application, it is Java interface, and we do something like this. We operate with a concept called a topology. Topology is the way how this individual message will flow through this topology and some transformation will happen. Majority of the systems that will be dealing with stream processing, they're dealing one event at a time. They're not dealing with a batch of events. They're dealing if the new event arrived, it will pass it through topology and will do some other things. Kafka Streams is the stateful stream processing framework, meaning that it has ability to preserve state between the runs. If you need to do aggregation, calculation, counts, sum, and all these kind of things that require you to remember what happened before, Kafka Streams has this for you. Now, the first thing is that we get the stream from our topic. There's some serialization, deserialization needs to happen. We need to figure out if there is a key available for this. So that's why we actually, finding the key inside the value. So we kind of like next step, we kind of transforming the stream. The next thing is that I want to get the latest record per flight number stored inside my application. So essentially, what you go and do, if you go and search this in your Kafka topic, you get the key, update your materialized view inside the flight store. Next thing is that I want to build some use cases on top of this data. So for this, I'm performing this kind of like a grouping thing. You don't have to kind of like read into actual API. Code is available, will be available on GitHub, and you can try to run this yourself. But the idea is that you actually writing Java code. I understand for Java users, it sounds cool. If they're SQL users, there's like kind of like every time when you need to do like new use case, you need to write your new topology, new application. It can be tedious for some of the people. Some people enjoying this. Yeah. So speaking about this, the query service. Now I'm taking the Kafka Streams abstraction and I'm wrapping this in the REST endpoint, so I will be able to have this the information about flights exposed, so non-Kafka users, like your REST endpoint users, can read this. So in this case, getting this read-only key value store that will we created previously for flight store, and expose this through this REST endpoint. And also, I do have delayed flights information that would be also exposed through UI. So in this case, I'm getting this, the all information that was stored inside is delayed by origin store previously. So Kafka Streams topology reads this data, do this all sort of transformation, store this inside state store that would be part of your application, and this service will expose this through REST in a JSON format. Does it make sense? Congratulations, you build your database. That's, Kafka Streams is a good framework for building database because it has everything that's, or streaming database, because this is how you do all these kind of things. And, I'm not going to talk about all these awesome features of Kafka Streams, like how you can scale this up and down, how the storage can migrate, and, you're not going to lose the data and things like that. So it's pretty cool. Let's see if my my topology is running. So inside the Confluent Cloud, we also have this kind of like the dashboard that allows us to see like what is going on here. It's cool. I mean, like it's cool. Like if you like in Java. So I'm serving my Java people here because I'm a Java champion, and I need to talk about Java on the Java user group, obviously. So that's enough of Kafka Streams. Any questions so far? Once again, everything is clear or nothing is clear. For me, it's difficult to understand which one is which. If it's nothing is clear, also let me know. Next thing is, since I start talking about database, okay. Now, we do have this awesome framework that can do all these awesome things with Kafka. Like, how about we build a database on top of this? Now, let's gonna talk about new thing called the streaming SQL. Now, the Java is cool. If you like this type of stuff, but there's a lot of things need to happen. You need to write the code, you need to compile code, you need to package code, you need to ship this code somewhere in order this to be running. And it's too much hustle for some individuals, and rightfully so. It's you want to solve the use case of querying the stream. You want to get your analytics. You want to get your reports. You want to get your, the stuff that your application needs to do or your boss asks you to do. How about there would be a system that allows you to write the SQL for queries? We'll have a streaming system like Kafka, Pulsar, Kinesis, whatever you have, as your first class citizen, meaning that it knows how to get the data from those systems. And it has ability to persist the results, because Kafka Streams has this ability to persist some results with the RocksDB and stuff. But also you want to kind of sort of, you don't want to reprocess this data all the time, right? Because what the Kafka Connect will do, or this Kafka Streams will do, if there would be no data available before, you will be reprocessing. And actually, it's a good thing. In Kafka, you will be able to reprocess your data if data is still available, if there's enough retention in the topic. So you screw up your Java application. Who cares? Just reset offsets, start from beginning, and you're golden again. Sometimes you want to have ability to kind of like maintain this, some sort of like materialized use, kind of like that will be constantly updating because you build your dashboard on top of this, and this dashboard needs to be updated. So storage and persistence of the results is very important. And another thing is that we're going to be talking that those systems. So KeySQL DB, anyone heard about KeySQL DB? Yeah, we're not talking about this guy anymore. So Rising Wave, Materialize, Time Plus, those things are kind of like cool, modern. I like Rising Wave because probably it's a heresy to say in the Java user group, it's not Java, it's written in Rust. It's actually pretty cool. Also, some people might say, like, but Victor, wait, what about Flink? Anyone heard about Apache Flink? Someone. Okay, Apache Flink, it's the distributed computational framework that can deal with bounded and unbounded stream of data. It can work on stream data and also work on the batch data. And it has APIs that available in Java. Not available in Scala anymore. Since Flink 2.0, Scala API is gone. It's only Java. Any Scala developers? Less and less and less. Like 1 year, there would be 0 Scala developers in the room. Any Kotlin developers? Seriously, guys, what are you doing? You're missing out so much. So yeah, the Java API available, but it has Flink has a SQL as a DSL for writing stream processing jobs. Will it make it a database? Well, let's count. So SQL interface for dealing with data, check. Streaming a data source as a first-class citizen, check. Persistence of the materialized view, kind of, sort of. So the project, the Apache Flink works, the community works on providing this like materialized view using different technologies like Pymon and stuff like that. But for all intents and purposes of this conversation, Flink is not a database. Why? There's my good friend, David Anderson from Confluent. He has a great video that explains to you why Flink SQL is not a database. Again, it's a whole, maybe I need to do another talk maybe next year about like why Flink SQL is not a database. Great video, great presenter, lots of knowledge. I learned a lot of stuff from him. We're gonna skip KeySQL DB. It was great, the great attempt that we did at Confluent. We use Kafka Streams as a foundation for building this streaming database. So essentially, we built this SQL interface on top of Kafka Streams. It has a concept of the persistent table abstraction that will be basically exposing our interactive query service in a sense that would be available similar to like materialized view. It has two cool features. My favorite was the push queries, where you can actually write a select star from flights where airline United emit changes. And all the flights information only from United will be pushed to my application, so I can get the real streaming here. And obviously the pull queries are the standard. Select star from flights where United, the airline equals United. So push query was cool feature. Since it was built on top of Kafka Streams, it has very intimate connection with Kafka, and it has a lot of things that were not helping this technology to thrive. Specifically, some of the bits with how it's scaled, how you need to think about your partitions. So too much details imposed to user of this database. So it was cool. It's still like, maybe you can find the sources somewhere here, but we're not talking about this guy anymore. Now, Materialized is the kind of like a data warehouse for streaming data. Was built as a part of Microsoft research on some of like data flow systems. Integrates with Postgres, with Kafka. Has a central abstraction of materialized view. It can be persistent and queryable, but there is also a very interesting thing that maybe number 4, how you can identify streaming database. And actually, it's very cool. So Kafka is our language to communicate in streaming world. So the systems that like to pretend or like gain some popularity, they build Kafka abstraction layer. For example, Pulsar has. You heard about Pulsar? All right, a few people. The Confluent people don't raise hands. Non-Confluent people, if you heard about Pulsar. It's another kind of like an interesting implementation of distributed transactional log, and it has a built-in Kafka compatibility protocol. So with streaming databases, in order to expose the query capabilities of the systems, this streaming database is actually providing the Postgres compatible wire protocol. What does it mean? It means that your client that knows how to talk the binary bits between your application and Postgres can talk to this system without changing the code. It doesn't mean that your Postgres SQL queries will work without changing. It doesn't, but the underlying communication will work. So you still would need to use like materialized style of queries, but you using the Postgres SQL to connect. So now we have a SQL as a language to accessing data. We have the streaming data sources as our first-class citizen. We have the persistent and materialized results, and also we have a Postgres-compatible protocol in order to support existing tools. I think that's kind of like 4 things you need to remember in order to identify proper streaming database. Now, I'm not going to spend the time here with this Rising Waves. I will point you to one of the recent episodes of How to Query Stream, where I actually went. So episode 7 is all about how to use Rising Wave for querying this. I will show you just quickly how this would look like, how your application would look like. This is SQL that will connect to my Kafka topic. And in Rising Wave, they use the concept of the source that will identify where this data will come in from. So in this particular case, it's just different properties to connect understand schema, so it can deal with the data that's stored in the schema registry. And after that, I can build different materialized views based on the data that is available to me. I created the source, I provided the structure, like in your typical data definition language in your SQL. And after that, this materialized view will be available for consumption. It will be constantly maintained by the system. And you can plug your, whatever JDBC application to do and query these results. Same thing with these queries. And you will see that even though everyone's saying like we SQL compatible, everyone will have slightly different style of certain things, which is, I think, kind of expected, but it's still odd. Everyone's saying like the SQL is the SQL, but different systems will use different style of SQL. And also stores the data. I can also run windowing functions. When you're running the queries on top of your streaming of data, you're rarely interested in query like everything. You're usually interested in some sort of like a small subset of streaming data. So like what was the sales from the last 5 hours instead of what was the sales for forever. It doesn't make any sense. So, and those, for example, Rising Wave supports ability to do like windowing operation, which is also available in Flink as well. So, this is something that you can do with this the streaming databases. Pretty cool technology. Yeah, same thing with the Rising Wave. Britain, it has a lot of ideas that was inherited from Flink implementation. Sometimes people call it, I don't know, like the Rising Wave people always say that no one calling that, but I'm calling that. It's kind of like a Flink implementation in Rust. It's fair enough. Even on their website, they have a comparison. Again, Postgres variable protocols, meaning that you will be able to just connect. In my demo example, I think I do have kind of yes the PSQL. Yeah. So for example, if I want to connect to this the Rising Wave, I'm just using the open source Postgres SQL client and get the data to connect. All right, so we are how far we are in? We're almost 50 minutes. It was just a few more things to point out. Now that's real-time analytics database. There are some cases where you need to perform inherently analytical queries on top of the real-time data with high low latency, with where's the word? Designed for high concurrency and low latency queries, meaning that this is database that you actually expose to your users, so they start querying this. Maybe you can back your API with this. Support streaming and batch sources, obviously, because OLAP most of the times runs on top of the batch, but streaming can be what's the word? were you kind of like joining the stream of you can enrich, enrichment. Thank you so much for helping me. Thank you very much, not sleeping. And it has like a conventional tables and SQLs, and has like an interface to traditional JDBC and all this kind of stuff. Super cool. It was developed LinkedIn the next door to where the Kafka was developed. Kafka was capturing all events that happen in LinkedIn. They wanted to build more use cases on top of this. So you go in LinkedIn, you click around, you like something, you write your post, you update your profile. All these events will generate the event and will be land in Kafka. Now, based on this information, they wanted to build, say, who viewed my profile, or like they want to build a kind of like the feed of the news, what happens in your network. So those things, if you think about this, those are analytical queries, because you need to run a query that has a multiple different dimensions, say one user will be dimensioned, like the geography will be dimensioned, years would be like some time aspect. And they built all these use cases, who viewed my profile, who viewed your feed, using this new system called Apache Pinot that runs on top of Kafka. There's a like almost instantaneous appearance of this data from Kafka. There's no delay, there's no batching. There's like a very kind of like a native integration between those systems, those things. It has a fantastic capabilities for indexing data, even like running on the massive amount of data. And usually used to expose this to outside world. Another example is ClickHouse. Anyone using ClickHouse? Druid, Apache Druid. Okay, few people. StarRocks. So those are systems also appeared in the last, again, maybe 3-4 years for solving this kind of like a real-time analytical use cases. Now, cloud data warehouses. Honestly, I don't have not much knowledge about those systems, except the logos are blue. I guess, like, if you think about this, like, if you think that you get one of those existential crisis moment in your life that you don't understand what you're doing this job. Imagine there's somewhere in the big corporation, there's a big meeting between like big people. They have like some names like a VP of something, and they're discussing the shade of blue that will be used for logo. Just think about this for a second. No, seriously. So it's another incarnation of the traditional data warehouse, but in the cloud. So you don't need to worry about storage. You don't need to worry about how this data would be stored and queried. Support ingestion from batch and streaming sources. Usually very biased towards like structured data, obviously, because the data warehouse was about the structured data. Data lake. It's kind of sort of systems that came up from the times where like we get the data, we will store it somewhere, and we'll figure out what to do with this data later. So in this case, ETL will switch into different form. So we extract, we load, and we transform somewhere like along the way. When we need to read this data, we can apply the schema on read. So its ETL will be changed into ELT. In data lakes, it's also kind of like very weird database, because your storage in one place, usually it's getting some sort of object storage like S3, and your query engine would be another place, and you executing this query, so it will be a higher latency for this. The reads are usually slow, and the data lakes were not kind of designed for streaming. So you can ingest from streaming system. There's connector that can read data from topic, send it into S3, and it will be stored there in bucket, and you will be able to query this thing. So one thing started as a GFS cluster, turns out to be S3 storage, and it didn't help much. Like I mentioned, we do have a ETL versus ELT. We wrote the data stored there. Whenever we need to read this, we apply in the schema and we're reading. However, something good actually came out of the data lake that we can use today, and I'll talk about in the next 10 minutes. Yes, you can drop the files in your in the GFS. You can drop the files into your S3 bucket, but you still need to have some sort of structure in order to read this. So that's why for the last few years, the emergence of open table formats that will describe the metadata. Your data is still stored inside S3. It's still some files there. But on top of this, you need to find the metadata that will tell you where the certain tables, where the certain rows will be stored, would be some columns will be stored. So those open table formats, and specifically the Iceberg data lake, I'm going to talk about specifically about Iceberg today. There's plenty of different formats, but they will define a metadata where your data will be stored. Why it is important? Now, remember ETL, right? So with the ETL, we try to get data from operational store in order to perform some sort of analytics. And with the data lakes was one of the solution to do this. With putting on top of this like open table format that allows you to have a unified layer to query data lakes. Now, Apache Iceberg provides a few interesting things. So it provides capabilities for defining a table format, defining schema, and also allows to perform interesting queries. For example, query the data that was available yesterday. So kind of like a fancy way of calling kind of like ranges, and this information will be built in and baked in metadata. So it would be faster to query this. But now we still need to have something. So we talk. I talk about this. You listened hopefully. You have operational data in Kafka. So your clicks, your transactions going into your operational store. You need to have query this with operational use case or with analytical use case. So you need to kind of like perform like ETL type of stuff. And this is kind of like a broken bridge between operational data store and analytical data store. And I think that something that we built and we saw in industry, there's some implementations of the same concept that come into play. You will see this all over the place now, is with Tableflow. So the Tableflow, we took this idea. So what about, we have this Kafka topic. We already have a structure. We do have a schema in this data. What if we can represent this Kafka topic in a format that can be easily queried? So we took this idea from the data lake. So we take this information that we store inside the Kafka topic and represent this as the Iceberg table. Now you don't do any ETL. So in our case, it is something that we taken care of in the background in Kafka Cloud. Some other solution involve kind of building kind of sort of like a real-time view on top of your Kafka topic. It's another solution. You have your data inside Kafka topic, and we present this data into Iceberg table. The way how it works in Confluent Cloud, for example, I do have my flights information, and it says Tableflow is syncing, and the data will be available in Iceberg format. So let me show you. Say, I'll take any other topic just to show you how this would look like. Enable Tableflow will require schema. So if I'm using schema registry, in my case, this schema will be inferred and will be used to represent this table in Iceberg format. And after that, we also providing the storage. We store the data and expose this data through the Iceberg catalog. Also, external storage, you can define your own bucket and store data in your place. Now, so I do have my flights, and hopefully I didn't lose the connection. Let's see if it's still there. I'm using DuckDB as example, but any system that that knows how to query Iceberg will suffice. If you're using Trino, if you're using Snowflake, you will be able to do this. Now, DuckDB it's another cool technology that you can run on your laptop, and it's small enough but also powerful enough to perform like the queries and analytics and things like that. So think about it, DuckDB is kind of like a next, it's a SQLite for your analytical data. So I connected to my this this Kafka topic, the flights topic, will be exposed as an iceberg table. I connected this and it will appear as an external catalog with my catalog, and my Kafka cluster will be represented as a database, and my flights information will be represented as a flights topic will be represented as a flights. We'll see. Hopefully it will work. Yeah, I didn't because unauthorized exception. That's fine. We can fix that. Okay, I came prepared. Okay, so we kill the secret. Let's see if this will update, and I will reconnect my warehouse. It's already database. We are doing the detach, and let's try this one more time. Okay, it's back. Hopefully it will bring up the and now I can see here because the DuckDB knows how to talk to Iceberg. This information is available, and all my topics that I exposed as iceberg tables available for query. So like if I go to my flights and let's see if this will able to bring some data here. It should you should bring this in any moment now, any moment. So the data about my flights, and now I don't need to do anything. Like I don't need to run connector here. I don't need to run any other external system. So I can connect and start writing SQLs against this table. And let's just describe my flights, get information. Maybe it's let me table name doesn't exist. It probably didn't refresh properly. Let's see if I can refresh it. Flights. No, it probably didn't refresh. So I'm talking too much, and my sessions are expiring. So the point is here now. This can be plugged directly to your analytical estate, your reporting stuff, and you will be able to perform any type of queries. The table flow available in Confluent Cloud. And also, there is implementation of table flow that available for any Kafka topic that comes from WarpStream. Confluent acquired WarpStream a year ago, but they still operate in a kind of like in dependent fashion. So you have a Kafka Streams that will feed into this iceberg table. Great for integrating with the existing infrastructure. If you have already like a Snowflake or Databricks and stuff like that, because those the table iceberg format and Delta for Databricks also supported in Confluent Cloud. I was showing this. If you want to play around with this, use my promo code. If you don't, let me know. You should do it. You should do it. You should play around. Actually, I don't know if this code is correct. So let me fix this because I think I have a much cooler code with much more bigger discount. One. Yeah, I think this code is better. So essentially, it gives you like $400 as a credit for 30 days. You can use it and abuse it. Try the different piece of infrastructure, play around. Don't enter credit card. Enter this code first. Because it will have a link saying I have a code, and after that people start calling Victor. I was on your meetup, but I was charged my credit card charge. I told you, didn't put your credit card. Put the code. So you put this code in, you will be missing the paywall. You can put the credit card after if you like it. Obviously, I hope you will. And as a conclusion for this presentation, there are no ideal solutions. I'll give you a roadmap that I was developing for the last year or so. I'm also in the streams. I'm going deeper. I'm just the writing code and looking into how all this technology wired together. There's no ideal solution. Something that worked for you, you should use it. So there is something that you already know and happy to use. Just use it. There's nothing wrong with it. So if you have a Kafka Connect connector that dumps data in your SQLite or your DuckDB for that matter, actually have an example that puts the Kafka topic into DuckDB. So sometimes you just go with whatever you have. You depend on infrastructure. You depend on other teams to maintain something, or you building or using the managed service. It's fine. It's okay. You solving the problem. It's better to be solved rather than being perfect, right? Another thing that many people like to think about this is performance. Performance is also very important on different groups. Like, what's the latency between how the systems will work? Like, if you start with Kafka Connect and you are not satisfied with the consumer lag, your queries needs to be operating on a more fresher data. Maybe it makes sense to take a look on the systems like a Pinot or ClickHouse or Druid. Performance, it's a big deal for some people. For me, community is the most important thing. When I start or I try to learn, I was into data systems. I tried to learn Spark, and people said, "Oh, you should use Scala for this." And I was like, "Okay, it looks like I need to learn a little bit Scala." And I was trying to approach different community. And it looks like without PhD, I don't have any rights to ask questions. Some communities can be like that. Kafka community is not like that. Kafka community, in this like meteoric, the rise of popularity of Kafka came from the great community that was created in Silicon Valley startups. It was created LinkedIn. After that, Netflix adopted this. They start talking about the things. They would go into the meetups. They meet with other engineers, and for a very long time, like Netflix was using some like old version, or Uber was using this version that didn't have like distributed capabilities. When Kafka was released, it didn't have distributed capabilities. It was added along the way in version 0.4 or 7, I don't remember. But think, when you're choosing solution, when you're picking up solution, think about where you can ask and go ask your questions. So another example, like my first language that I learned, programming language, was Pascal. Not because it was cool or whatnot, because I knew the guy next door who I can ask and bug the questions about this. Not because it was cool and I know that's going to be my future. No, I knew that it would be someone that I can ask questions if I have so. If there would be Scala guy next to me, I mean, the situation might be different. Maybe I was not so bitter about this, but community is important, and my job in Confluent is to help to foster this community, make sure that your questions is answered, and some of the interesting things that you're developing, I get inspired to build some demos to talk other engineers. So it's both ways. I like to kind of like get something from this, and I also like to give something back to community. So there's a plenty of things that you need to be in. Kafka is on top of the things. There's a sea of monster in between. It's a cool journey, and I hope in this presentation you learned something new. Maybe you also were a little bit entertained about this, and I hope it also will give you this framework that allow you to evaluate the product that you look into, query your freaking stream. That's the story. That's all, folks. Again, no ideal solutions. You need to know what exactly requirements. And with this, my name is Viktor Gamov, and as always, have a nice day.